All right, students, we're going to talk about the 5-3 notes. Okay, we're talking about the slope-intercept form. So slope, we've talked about that before. That's how you move. Okay, that's how mathematical stories change with movements, adding or subtracting and moving left to right. Today we're going to talk about the y-intercept. Now this is a predestined place to start on the y-axis. So we all know that a basic coordinate point system, this is the x-axis and this is the y-axis. So the y-intercept tells you where to start on this line, and then the slope tells you how to move. Okay, so it's kind of a crash course right there. But here's some of the problems you're going to have. They want you to simply identify the slope and the y-intercept when they give you a slope and y-intercept equation. So it's basically saying, hey, what are the parts of this equation? Very simple. So we have y equals 5x minus 2. So if you look at the equation, slope-intercept form, the slope is always connected to the x, and the y-intercept is a number that's all by itself on the right side. Well, it could be here, it could be there. These two things can be interchangeable, but this is the best way to write it. Okay, so the slope, it's the number connected to x, so that's 5. And the y-intercept is the number that's by itself, that's negative 2. There you go. So your slope is 5, and your y-intercept is negative 2. Notice you could write a negative y-intercept as plus negative 2 or minus 2. It's the same thing. So how would I graph this? I'm kind of cheating a little bit here, but if I wanted to graph it, I would start at negative 2. Okay, and the slope is 5. I like to say 1 to the right, change in the height. So I'd go over 1 and then up 5. So 1, 2, 3, 4, 5. So my next coordinate point will be right there, and then I play connect the dots. So that's where I start, and that's how I move. Again, I'm getting ahead of myself. We're talking about just identifying the slope and y-intercept. So look at the next one here. Here's your got it question. This is for you in your notes. What are the slope and y-intercept of this equation? There's your slope, and then there's your y-intercept. Now, I'm not going to lie, 2/3 is a pretty nasty y-intercept. It's nice when your y-intercept starts on a nice whole coordinate point, but 2/3, I'm pretty sure you could still manage that. Plus, you can always plug x values in, and y values will come out, inputs and outputs, and then you could graph it pretty quickly with those coordinate points. All right, so again, this is how you move. This is where you begin. I like to think about this is where you start, and this is how you step. We'll talk about that when we graph more of them later. So what do we got here? How do you graph, how do the graph of the line, how does the graph, is that a typo? How does the graph of the line and the equation in part A change if the y-intercept is moved down 3 units? Oh, so instead of at negative 2, you want to move down 3 units, 1, 2, 3. Let's see here, 1, 2, 3, that'd be at negative 5. You still go 1 to the right, change in the height. So now, this next corner point would also move down 3. So over 1, up 5, right there. So if you were to graph that line, they'd be right next to each other. They'd have the same slope because the only thing you're changing is the y-intercept. So again, down 3 units. So if you did minus 3 more, you'd have y equals 5x minus 5. So again, look, minus 5 over 1, up 5. There's your next coordinate point. Okay, that's problem number 1.